Today's lesson is going to talk about a phrase that we use in proof sometimes, and it's called CPCTC. So I want to start by saying when you have one of these 5 postulates, SSS, SAS, and so on, all you need is 3 parts of a triangle, and you can use one of these theorems. So you don't need like tick marks and rainbows and everything, just certain parts in order to make a theorem. The good news is that once you do decide that you have enough for, let's say, SSS, then you're allowed to go ahead and mark all the other matching angles as well, because you already said they're congruent by SSS. So basically, here's what that means. Say you see 2 triangles, and I ask you, are these triangles congruent? You would say, oh yeah, I see ASA. Okay, so the triangles are congruent because of ASA. Once you have said that, you are allowed to go ahead and say, well then, these angles will have to be the same, because I've already said the triangles are congruent. These sides will have to be the same, and these sides will have to be the same. So once you have proven your triangles are congruent, you're allowed to go back in and mark all the other unmarked pieces. That is called CPCTC. That's the phrase we use for short. And this is what it stands for. The C is for corresponding, the P is for parts of congruent triangles are congruent. So it's just kind of saying, basically, hey, if these are the same, if they're the same triangle, then all the other unmarked pieces are also the same. You've already used CPCTC a lot for me. Anytime you do a problem like this one, you're using CPCTC. So if I give you a pair of congruent triangles, by listing all the component pieces that are congruent, you're telling me, oh, because they're corresponding parts of congruent triangles, they are all equal to each other. So you will have to know what CPCTC stands for. That's something that they train and then quiz you on. So we want to just make sure we're comfortable with that. So let's say you're asked to prove that angle A is equal to angle Q. Okay, that's what you're supposed to finish with right here. Well, you're going to first try to see if the triangles are congruent by using one of the smaller theorems, like angle side. Once you get to that point, then you can go ahead and say, okay, angle A now equals angle Q because corresponding parts of congruent triangles are congruent. Of course, if you don't want to write all these words in your proof, you can just write the phrase CPCTC. So we're going to practice that right now. Make sure that we have that under our belts. The good news is our proofs really aren't going to change that much. It'll just have one extra step. So it says we copy our given down. It says PR bisects angle QPS, PQ equals PS. So what I would do is I would mark PQ, PS from the given. And then because you see the word bisect, you know you'll have definition bisect in your problem. The tricky part is figuring out what do you draw. So after the word bisect came an angle. Well, angles get rainbows. So we're going to find angle QPS, and we're going to put rainbows in it. So what you have to do is you have to name each angle that has a rainbow. So this will be the first angle from here to here. That is angle QPR. The second angle from here to here is going to be SPR. So there's your 2 congruent angles. So right now I see I see a side and an angle if I just look at one triangle. So that means I'm going to need this reflexive property right here. And of course I want to say that PR equals itself. Reflexive means equal itself. And now you can say the triangles are congruent. So we have triangle QPR is congruent to triangle SPR because of, in this case, it's side, angle, side. So normally we'd be done at this point, but be careful. You are asked to prove that angle O equals angle S. You did not have that in your proof yet, so we need to finish our proof with that. So now I can put, oh, that should be a Q. Oops. So now I can put rainbows at Q and S because they are corresponding parts of congruent triangles, so they are congruent. So our next proof, it says CD is perpendicular. You might want to write that off to the side, that an upside down T means perpendicular. We haven't talked about that for a while. And for some of you, you might not know perpendicular means basically 90 degrees. That's what you have to know. Perpendicular means makes a 90-degree angle. So it says that CD and AB are perpendicular. So you want to find CD and AB. You're going to put 90 degrees in the angles. So that is actually a vocab word. That means you will have to write definition. And you can write perpendicular or you can use the symbol for it. But we have to say that angle, and this time I'm going to put a 1 and a 2 in here just because I don't feel like using 3 letters. Angle 1 and angle 2 both equal 90. That's a way you can show that both angles are 90 really easily. We also have to do definition of midpoint. So we have to look at what comes after midpoint, and it's a segment. Well, segments get ticks. You need to find AB, and you need to put tick marks on both sides. So in one triangle, you have tick marks on AD. In the other triangle, you have tick marks on DEB. So right now you have a side and an angle. So we're going to use the reflexive property. And we're going to say that CD equals itself. 1, 2. Now you can go ahead and say, oh, I see SAS. That's good. So now I can say the triangles are congruent. Triangle ADC is congruent to triangle BDC. But remember, you were asked to prove this, so we need to finish with that. CA, therefore, equals CB because of corresponding parts of congruent triangles being congruent. The last thing I have in here is that you cannot use CPCTC unless you have used SAS, SSS, ASA, HL, or AAS. So when you're writing your proof, okay, you have to have one of these, SSS, whatever. You have to have one of those theorems before you use CPCTC. So you always end with this. It cannot go anywhere else in the proof. That's a good rule of thumb.